started. Welcome everybody to another Weiler Wednesday webinar. Can't believe it, it's our last webinar in the month of May. You know what they say, time flies when you're having fun, right? My name's Nate Schmidt, I'm the Director of Marketing at Weiler Abrasives. And today I have David Jaskovich joining me. He's our Abrasives Manager, Abrasive Specialist Manager, get that right? And he's been with Weiler 36 years now. So he's a great person to cover the topic today, which is pro tips for selecting the right abrasive for the job. Before we get into the webinar, just a couple Zoom tips. Many of you are probably becoming Zoom experts by now, but just in case you're not, we'll go over the ground rules. Everybody's line has been muted just to prevent any background noise. We will use a couple functions within Zoom throughout the webinar. The first is the chat function, and we'll do that about halfway through, where we'll give an opportunity to win a giveaway. And we'll ask you a question. We'll ask you if you respond with your answer in the chat function for that question. The next function we use is the Q&A function. And you can submit a question at any time throughout the webinar. We'll do Q&A at the end of the webinar, but feel free to submit the question at any point during the webinar. And the last function we'll use is polls. And we'll pose a poll, and you'll see that pop up on your screen. We encourage you to participate by entering your response to the poll when you see that pop up. We also want to give a quick update on our response to COVID-19. We've talked about this in past webinars. Obviously, we still continue to operate as an essential business and continue to provide products that are mission critical to many of our customers. And not much has changed on that front, although I did want to give an update. About 3/4 of our sales team is now back in the field, and obviously they're following all the precautions that are prescribed CDC, local and state officials as they get back into the field to help our customers, including wearing face masks, social distancing, and following a pre-travel checklist. I want to make you guys aware that the team is there to support you, and whether that's remotely or in person, much of our team is getting back out into the field to continue to support our customers. So that's a good news for us, and we look forward to more of that as we continue into June and come out of this pandemic. So without further ado, I'm going to hand it over to DJ. DJ, take it away.
All right, thank you, Nate, and good afternoon, everyone. Again, I'm David Jaskovich, and I'm the Abrasive Specialist Manager for Weiler. Today, we're going to discuss abrasive options for right-angle grinders during metalworking applications. We'll compare the most common items and evaluate their advantages and limitations while discussing initial purchase price and overall cost considerations. And before we're done, I'd like to pass along a couple tips to increase productivity. And we'll allow some time at the end to answer any questions you may have. Move to the next slide, please. So, metal conditioning requires many types of abrasives for cleaning, metalworking, blending, and finishing. There are many applications, such as preparing surfaces for painting exceptionally large surface areas, such as ships or bridges, that might require shot blasting, or smaller jobs like removing burrs in CNC equipment that might require one of our Nylox abrasive nylon brushes. And there are countless applications that might require finishing with belts or shop rolls or just plain old sandpaper. Today, our discussion is going to revolve around abrasives used on right-angle grinders. Next slide, please. All right, different options. To begin, let's review the most common types of abrasive tools for use on right-angle grinders. Although wire brushes do not contain abrasive grains, they're often identified within the abrasive category. Wire brushes do not remove base material, just loose surface material like paint or light rust or burrs. We're not going to include the brushes in our discussion today. However, if you didn't have the chance to view our webinar last Wednesday, I highly recommend you review it on our website, as our category manager for MRO, Ron Vogt Jr., provided an excellent review of wire brush styles, their configurations, usage, and their benefits. Perhaps the most common abrasive product used on right-angle grinders are bonded abrasive grinding wheels. They come in a few configurations shown here. Type 27 is by far the most common, and it's generally what comes to mind when discussing grinding wheels for right-angle grinders. The Type 28 wheels, also known as saucer wheels, are designed for aggressive grinding at lower grinding angles, and type 11 wheels, also known as cup rocks, are excellent for large surface areas and heavy stock removal. Flap discs. Flap discs are coated abrasives utilizing overlapping flaps. They're manufactured in a type 29, which is also known as conical style. They maximize the surface contact for aggressive stock removal on flat surfaces. Type 27, or flat flap disc, provides smooth grinding, blending, and finishing on flat surfaces and slight contours. High-density discs conform well to irregular surfaces, and the angled disc is kind of a hybrid to a type 29 and has a curved flaps that are ideal for grinding fillet welds, T-joints, and hard-to-reach areas. And resin fiber discs. They're coated abrasives and have two basic configurations. It's a plain arbor hole, which requires a lock nut to mount it on the backing pad, and a 5/8 version for easier mounting. Resin fiber discs do require a backup pad for support. Next slide, please. So, what influences the product? For each style of abrasives we're discussing, there are influences beyond the product itself that impact the results of the grinding operation. For example, speed and size determines how large of an area is covered and how often the grains cut the surface of the material. Obviously, the more often the grain contacts the surface, the more efficient it becomes. Amperage or horsepower is required to maintain the appropriate speed of the tool. Lower amp or horsepower tools will generally greatly reduce speed when pressure is applied and reduce the RPM. To maintain amperage, also consider the extension cord gauge and the length, and consider air pressure and controls for pneumatic tools to maintain the horsepower. Applying pressure by pushing too hard on the abrasive product produces more heat and generally reduces the life of the wheel. It also increases the opportunity to damage the workpiece and makes for a long, hard day's work for the operator. And the angle of approach is an important aspect for disc style abrasives. It can deviate by style. However, generally speaking, a higher angle of approach, such as 30 degrees, produces a more aggressive grind. However, it reduces the disc life, and a lower angle of approach, such as 15 degrees, increases the disc life. However, it reduces the aggressiveness. And the part geometry, whether it's flat, contoured, has angles, or sharp edges, influences which product is best suited for that application. And I put the term here, environment. It's like consider an area such as a ballast in shipbuilding. You know, an operator might take up to 30 minutes to work his way through the ship ballast to get to the work area, and he can't carry much equipment with him. He'd obviously want a product that has a longer life. You know, in a different environment, say a manufacturing facility that's running at 110% of its capacity and can't keep up with customer demand, they might look for an abrasive that consolidates two processes, such as grinding and finishing. This would increase productivity and help meet the customer demands. Last, but certainly not least, the most expensive part of right angle grinding is the operator. You know, an experienced, well-trained operator uses tools to their full potential, and it's critical to efficiency and safety. Proper training to an operator on how the product is designed to be used is a great investment. So ask your Weiler representative about how we can help. Next slide, please. The grain. Okay, so although each product is built differently, the abrasive grain is the material that does the cutting. There are three main types of grain used in metalworking. Each has its own characteristic and degree of cost difference. Aluminum oxide is a good, durable, general-purpose grain. It dulls during use, and it's the least costly. Zirconia alumina is a grain which fractures minutely rather than wearing away during use. This self-sharpening grain holds up well in high temperature and extreme pressure applications. And ceramic alumina. This grain is also self-sharpening and fractures and maintains a high cut rate for the entire life of the grain. It performs great on hard to grind metals. And it's also the most costly of the three grains. Next slide, please. The grit. Abrasive grain size impacts the cut rate and the finish produced. A coarse grit has a heavy removal rate, while finer grits have a better final finish and require less pressure to be applied. Abrasive grains are sized by passing them over screens having a certain number of openings per linear inch. The number of openings per linear inch in the screen through which the particles just pass determine the grit size. As this chart shows, the higher the number, the finer the grit. Next slide, please. Let's talk about some basic construction. Okay. Although the grain does the cutting of each product, the construction of each impacts the delivery of the grain. So grinding wheels basically consist of the grain, the bonding agent, and fiberglass reinforcement. They're pressed together and cured. The final product is very rigid and has the feel of a rock. Flap discs consist of the same grain coated on a cloth-type backing made from cotton or polyester or a combination of both. The flaps are overlaid and glued to the backing plate, which can be made from aluminum, a composite, or a phenolic backing, which is made similar to a grinding wheel with fiberglass reinforcement. Weiler resin fiber discs utilize the grains adhered to the fiber backing with two resin bonding agents. By electrostatically depositing the grains, the largest side of each grain is adhered to the finer backing. This ensures the sharpest point of the grain is exposed to the work surface and produces a very fast initial cut. Next slide, please. The bond. Okay, so with bonded abrasives, combining the grain selection and the grit size with the appropriate bond creates many variations of grinding performance. We've already talked about the characteristics of the grain and the grit size. However, when determining the overall life and cut rate of the wheel, we really need to consider the bonding as well. Okay, the bond can increase the productivity and effectiveness of the grain by simply allowing that particular grain to be optimized. When a stronger bond is created, it retains the grain for a longer amount of time. Therefore, a wheel that has a stronger bond typically has a longer life. A harder bond or wheel typically works well with a stronger, more durable grain, such as the zirconia alumina or the ceramic. A softer bond wheel typically breaks down faster and produces a faster cut rate as the grain is shed and new sharp grains take its place. This does, however, allow for reduced overall life of the wheel. Take a look at the chart. Okay, note that the closer in the alphabet the grade reaches towards Z, the harder the bond is. Each wheel should be marked appropriately with the grain, grit, and the grade. Now, the example we see here is a Z24T. It's a zirconia alumina grain, 24 grit, with the T grade bond, which is fairly hard. Overall, one bond is not better than the other. As we discussed earlier, each individual facility has its specific needs. Combining the appropriate bonded wheel with the appropriate power and speed grinder will really determine its overall effectiveness. I think back last year I was helping a customer with this grinding application, and he told me he'd already tried ceramic grain wheels, which were dropped off from a local distributor salesman. And this guy was told that they are the best grinding wheels available. He told me that if these were the best from that particular manufacturer, he'd hate to see the others. The ceramic wheel didn't impress him at all. I noticed he was using 7-amp angle grinders, and the bond on the manufacturer's wheel was pretty hard, which is normal for wanting to maximize the life of the more expensive grain. I suggested he try a softer bond wheel and also change the grain to aluminum oxide. He was very impressed because the wheel ground much faster, it didn't load up, and had a lower purchase price. Basically a win-win-win. Bottom line, the softer bond allowed for his lower amp tool to break down the wheel appropriately and really produce a faster cutting, efficient wheel. Next slide, please. So speaking about the aspects of grinding wheels, they're by far the most durable. life expectancy of a grinding wheel far outdistance flap discs and resin fiber discs. Their initial purchase price is more than a resin fiber disc. However, they cost less than a flap disc. And based on their long life, they have a low overall cost of the product for the amount of parts that are ground. That doesn't necessarily mean they have a low cost for the labor being applied. Okay? They're not conformable. Basically, they feel like a rock, and they don't lend themselves to contoured surfaces without great care. And also, since they're not conformable, grinding wheels can move and easily gouge the work surface. Grinding wheels provide a rough finish, and they're not generally used for finish work unless a secondary operation is included, such as finishing up with a resin fiber disc, and perhaps not a large concern. However, the noise level produced by a grinding wheel is significantly higher than that of a flap disc or a resin fiber disc. Next slide, please. So a little bit about coated abrasive construction. Earlier I mentioned how our resin fiber discs are manufactured using an electrostatically deposited grain. The drawing here gives a better illustration of the process Weiler utilizes. Basically, the raw grain is moved along a conveyor, which has a positive electronic charge. When the backing material is introduced with a negative electronic charge, the heavier part of each individual grain is pulled into the backing and the base resin coating. You can see where the sharpest point of the grain is now exposed to the face or working side of the disc backing. Then the final size resin and optional top coat are applied. This process ensures the fastest cut right out of the box. And not all manufacturers use this type of process. Some basically just spread the grain and embed them in the resin where they fall. This is certainly a less expensive way to manufacture. However, it doesn't provide the fastest cut rate. Next slide, please. So resin fiber discs, one of their greatest strengths is that it's the fastest cutting product in this group. They also have the shortest lifespan. They work well as a grinding and finishing tool. However, they're susceptible to tearing on the outer edges if they're forced into a corner or a hidden edge of the workpiece. Depending on the grain type, they have a tendency to work best right out of the box, as the grain rate and finish deteriorate as the grain wears and is released from the backing. They have good conformability. However, it's based mostly on the hardness of the backing pad. Resin fiber discs do have the lowest initial purchase price after the backing pad has been purchased. The performance is greatly influenced by the type of the backing pad that's used. So try to utilize one, like Weiler's, that helps dissipate the heat and helps the disc perform to its fullest potential. Next, please. Flap discs. So Weiler flap discs, we also use electrostatically deposited grains, and they have a fast cutting rate, and they last much longer than resin fiber discs. However, they don't last as long as a grinding wheel. They work well to both grind and finish, providing a consistent cut rate and a finish throughout the life of the disc. Using a high density disc provides the most conformability, as they conform well to contoured surfaces. The angled style disc produces efficient grinding of fillet welds without tearing apart the outer edge of the disc. Flap discs are also the most forgiving, as there's a cushion effect should the operator misapply it. This product does have the highest initial purchase price. However, its value is in the combination of cut rate, life, consistency, and reduced work damage. The product generally is more appealing to the operator, as it has a smooth operational feel. It produces less noise and odor than a grinding wheel, and it has less change over time and produces a more consistent cut rate and finish compared to a resin fiber disc. One of flap disc's other advantages is the large amount of variations available. Once the appropriate product is identified for the application, they work great. However, many times customers use the incorrect flap disc for the job and assume that all flap discs won't do the job properly. It's an area that can seem confusing. I'd ask that you utilize Weiler's flap disc selection guide to help you in your decision-making process, or contact one of our representatives for expertise when choosing an appropriate flap disc for your application. You know, a good example is one time I was asked to come into a customer's manufacturing facility to help reduce cost. You know, the general manager told me he needed to reduce costs as they had recently obtained a large new customer and the margins were tight. He introduced me to the operator on the floor and said he would walk me through what was needed. You know, the operator began explaining, you know, how many pieces they produce with the grinding wheel they've always used. You know, they tested it against every disc on the market and found this to be the longest lasting. You know, he's doing his job. He's really just trying to get more life and reduce the cost of grinding per piece. You know, after reviewing the entire process, I asked him to try a flap disc. He said he'd tried them before, however, they didn't last as long as grinding wheels. I agreed, but I asked him to try it anyway. You know, as we counted the pieces ground, he increased the amount of parts per hour by 25% and also made a visually more appealing part. You know, we solved issues as mostly the low margin for this part was primarily being driven by the overtime required to maintain the demand. You know, the increased productivity was enough to eliminate overtime and bring the high volume business closer to the original projected profit margins. Next slide, please. So what's important to you, right? To sum it all up, the best abrasive for use on right angle grinders depends on your requirements and what your definition of good is. You know, this chart might help with the decision-making process. However, it doesn't include factors that each shop faces, such as some shops buy strictly on the purchase price of the product. You know, however, this doesn't consider the largest cost of the overall process, the labor. Some shops will base their decision on the life or longevity of the product. Again, a clearly easy way to base a decision on the overall product cost. However, it doesn't consider labor or the efficiency of the shop. Some shops will also choose based on the versatility of the product. Again, it's a clear choice for a smaller volume shop with multiple applications for grinding. However, this is the least effective for large volume shops that require higher efficiencies. Along with other portions of our value package, some of Weiler's most beneficial support programs are our cost and test analysis and site evaluations, along with our safety and product trainings. You know, let us help you determine which product is best for your particular application. We'll review the tools, the materials, and your process before and after the grinding to help you meet your requirements the most effective way. For example, our testing at your facility will consist of using your coworker and his or her grinder, working with your application. We'll weigh and measure the results of each product tested, and you using, you know, your labor rates and your product usage and costs. We'll give you a complete analytical review of your annual grinding costs based on the overall product cost or the labor, or both, for a full unbiased evaluation. You know, Weiler offers these services free of charge, and I highly recommend you take advantage of these offerings by contacting your local representative for additional details or to schedule an appointment. Move on, please. Next.
All right, thanks, DJ. So we're going to do the giveaway here quick. So again, we're going to give away a mobile power pack for your mobile devices. And the way you'll answer this question is by posting your response into the chat function in Zoom at the bottom of your screen. So the first person to answer the question in the chat function will win a prize, and we'll announce that at the end of the webinar. So the question is, besides the product itself, name one factor that influences the results of the grinding operation. Again, besides the product itself, name one factor that influences the results of the grinding operation, and the first correct response will win the mobile power pack. DJ, I'll hand it back to you to finish us off.
All right, thank you, Nate. I do want to finish up by just passing along a few tips. If you could move to the next slide, thank you. So for an initial cut, right? No matter which abrasive product's being used, you should always enter the workpiece using a backstroke or a pull stroke on the grinder. Right out of the box, these products bite or dig into the material work surface. Backstroke will help the disc break in and avoid gouging the material, and also avoids a potential kickback of the grinder. Once the wheel is broken in, long, even pressure strokes for both the pull stroke and the push stroke produce the best results. And remember, don't use excessive force, as this will not increase the cut rate. However, it will break down at a faster rate, reducing the disc life. Okay, one more, please. We'll talk about grinding fillet welds, right? So a very difficult area to grind for appearance are fillet welds and T-joints. Weiler's angled flap disc is designed to use the curved flaps to efficiently grind the surface without gouging the material or severely damaging the abrasive disc. Flaps wrap around the edge of the backing plate, optimizing the flap to metal contact, and provides an exceptional feel and control while grinding. They also provide versatility in repair and rework applications where it's important to focus grinding in a small area while maintaining the impact to the surrounding workpiece. Also, we discussed earlier, right, the shape, sizes, and environments which we work might require an extreme angle of approach, such as when manufacturing ornamental railings or stringers for metal stairways. The shape of this flap disc allows for grinding and finishing in areas that are considered difficult to finish because of the extreme angle of approach required. And we manufacture angle discs in both 4.5-inch and 5-inch diameters. Well, that finishes up my tips, Nate.
All right, thank you, DJ, for that. Appreciate it.